So let's begin chapter 1. Like I mentioned, chapter 1 is a lot of definition. It's a lot of definition driven, and you have an ebook on Connect Math for you guys to read. So what is statistic, right? So what is statistic? In the sense, statistic is just a collection of data. You collect your data, you organize your data, you present your data, and then you make a decision on your data. You will see in here at the end of the class, not the end of class, the end of the semester, we will give you this data, and then you have to calculate and tell us, is it a good idea to continue the investment, or should we just stop the investment? You have to make that decision. So that's our goal. We will slowly progress to that item where you can make a decision, where you have to calculate and make a decision. Okay. So again, the first half of the class will be collect data, organize them, and look at the data. The second half of the class will be make a decision. Okay. But before that, in statistic, there are two items that you will see or you will hear a lot, and your job, your main goal is to determine which one is population and which one is sample. So the population is basically the number that include every single item that you want to collect, right? The people that you want to collect, and the sample is just a small portion of that. Right. So if I were to able to collect all of the Delgado student major, then that would be my population. But if I cannot collect all of the Delgado major student major, then I can just collect you guys, right? Since I have you guys in my class, I just ask you guys submit what is your major, then you guys will be a sample of that Delgado student, right? All of the Delgado student will be the population, and you guys will be the sample. And as you will see, in here, it's hard to collect the population, and statistic, you will see that we will deal a lot with sample. So the number that represent population, we call that number will be parameter, and the number that represent the sample, we call that statistic. So as you can see, the statistic is the number that describe or represent the sample, and that is your class. Ladies and gentlemen, you are in a statistic class. So you can see, or you can expect, that we are dealing with a lot of sample item, right? Like I just mentioned, it's hard for me to collect all. I mean, I can go to the database and get all of the student, for the fall semester, all of the Delgado student, and get the major. But again, I don't want to go to that extent. What can I get my hand on? Which is I can only get my hand on the sample, which is I can ask you guys, send you guys email, say, can you respond what your major, right? So again, statistic is the number that represent the sample. Okay, so again, your goal, as you will see, or if you start the homework already, this is the typical question that they ask you, is determine if this item, I thought I did not give the question. Determine if this item, the average age of the employee in a certain company is 35. So the 35 years old is the age of the employee, right? The average age, right? So looking at this thing here, what does this number represent? Which is, again, do you see why is this number a parameter? Again, one thing is parameter because it's related to population. Why is this population? Because this is every employee in this company. Whatever this company is, the employee at this company, that's what we have, right? So in a sense that this is our parameter item, in terms that because that this is the population, all of the employee. The other thing, or one thing you will see a lot in chapter 6 and chapter 7 and chapter 8, you will see this word a lot. And one thing I tell my student is, whenever they ask you this, which is if they tell you this in a survey, if they tell you that in a survey, then that will be your statistic number. Why is a statistic number? Because looking at this thing here, if you look at the high school student, there are million and million of high school students, right? Looking at this thing here, we only have 400 high school students, and with this 450 high school students, 45% of them say that they intend to go to college, which is the 45 represent the statistic, because we did not get every single high school student to respond. And most of the time, the survey, as you will see, that the survey will be statistic number, because not everyone answered the survey, right? Except the censor. The censor, which is this year's, you have to fill out that censor every 10 years. That censor is parameter, even though you say, wait, that is a survey, but the censor is a parameter because they send to every single people in the United States. Okay, so the censor, that's the only survey that is parameter. But again, the most of the time, if you watch the news now, most of the news, they say in a recent survey or in a recent poll, President Trump have 45, percent rating or something like that. Again, not everybody answer or in that survey or in that poll, right? I didn't answer it. So most of the time or always when they say in the survey, it will be a statistical number, okay? And again, this one here, just like the example I mentioned to you guys earlier, of the students enrolled in Delgado, 82 of them are full-time, which is, again, all that is include all of the Delgado student. And as you can see right here in a recent poll, just like I mentioned, if it's in the recent poll, this will be your statistic number. So again, this is just an idea of what kind of your question would, most of your question will be in chapter 1, which is they will, most of the time or all of the definition, you have 2 items. You have to determine what is the difference between, or how to determine which item is which, okay? So the first thing is parameter is the number related to your population, and statistic is the number related to your sample. The next thing we have is a different way or how to sample your data, how to collect your data, right? So one thing to collect your data, first thing is make sure that your data are randomized. Meaning, again, a sample random sampling basically tell you is when you collect your data, make sure that your data is not biased and all of the people or all of the data you collect is equally likely to be able to select in your sample. Okay, and again, sample meaning you just get a group of item, right? So same thing with this item here. In terms of the technique, for us, there are 5 different techniques to sample or gather your data. So the first technique is a sample by convenience, right? So convenience is basically, again, this thing here, they tell you is not well defined in terms of a random method. The reason is this is just convenient to you, right? It's just convenient to you. Most of the time, it is not in terms that it's not fair for everyone else. So for instance, if I want to ask people, do you like Coke product or Pepsi product, right? So one way I can do is I can just stay in front of Walmart or Winn-Dixie from 10 to 11. That's convenient to me because, again, it's close to my house and that's the time I'm available. I just stay in front of there and say, do you like A, Walmart? I mean, not Walmart. Do you like A, Coke or B, Pepsi, right? So again, it's convenient, or in the sense, if you look at your textbook, they have the example of a central block, the central block, and they have like 100 of row and column. And then you have to test to see what is the weight of each block. So there's no way you want to take 10 of them off and test the bottom rock, right? So again, so this sample is just convenient. You just take the top layer and just measure those weights or measure those diameter, right? So it's just convenient to you. So in a way, that is not really well defined in terms of the randomized, because it's just convenient. It still work, sometimes you still force it to work, but it's not randomized, okay? The other randomized is stratify versus clutter. one thing is stratify and clutter, they are very similar, but the difference is for a stratify, you divide your data into a specific category, okay? Let's say you have a survey question, you have a 10 survey question, and you want to ask people at Delgado, right? But instead of ask anyone, what you do is you say, okay, I want to ask this group of freshmen, this group of sophomore, this group of junior, this group of senior. So you divide each of your group into a category of first year, second year, third year, 4 years, right? So that is stratify, because each group of people is still random. It's just that it's in that specific group, right? The difference between stratify, which is in each category or in each strata, right? Different from clutter is instead of divide them into different category, you just divide them in different area. So for instance, let's say Delgado, the City Park campus is big, right? Instead of divide them into freshman, sophomore, junior, senior, you say, okay, let me go to building 1, ask whoever in that building 1 answer this survey question. And in that building 1, they can have junior, senior, sophomore, doesn't matter, right? You don't care about the individual category. You just say, okay, that is in building 1. I go to building 2. I ask people in building 2. I go to building 3, meaning again, you just circle each area. So clutter is one specific area that you want to ask, but again, they have mixture of item in there. Strata is a different category that you try to ask, okay? It's still randomized. It's just that it's just specific criteria that you want to have so that you can compare among the freshmen versus the sophomore versus the junior versus the senior. For clutter, we don't know. We don't know if they are freshman, sophomore, junior, but again, they can be a mixture in terms of that, okay? The other two, which is the strata systematic sampling. This is basically tell you that you create some system in terms that you, let's say you have 1,000 call. The easiest way is to look at the call manufacturer, and they want to test, but they have 1,000 call. They don't want to test 1,000 call to see which item, the brake or the airbag or the window, which is not working out, right? They don't want to test the whole 1,000 call because it's too much, right? And again, I use 1,000, but they can manufacture 10,000 and stuff like that. So what they do is they say, okay, each call line up in the assembly line, and we put a number in each of the call. And we will say randomly, we will start at number 2, and every 8 position after number 2, we will take that call out and test. So instead of testing 10,000 or 1,000 call, we just test a fraction of that, right? We will start at number 2, and every 8 position after number 2, which is 2, 10, because 2 plus 8 will be 10, 10 plus 8 will be 18, 18 plus 8 will be 26. So again, each 8 position after number 2, that will be your systematic, that is the system. And again, if you remember back in 2010 or so, a lot of automobile have a recall, right? Because sometimes this system, you just pick out, so happen that all the call that you pick out work fine. And then you release that batch, and then the malfunction one is in the, you send it out. And that's why they have a lot of recall in terms of those items. So again, systematic is just basically you put them in some system, and then you randomly choose a number and choose the position, and then you just randomly take them out and test. The last one, the volunteer response. This thing here is not really a good way, but it still work. The reason why it's not a good method to collect the item, because most of the time the volunteer response would be biased. So for instance, if you driving on the highway and you look at the truck and they say, how is my driving? Please call this number, right? You never call that number to respond, oh, this driver drive very safe, he signal, you never call to report that he do good stuff. Most of the time you call that number because he cut you off, he drive reckless, right? So most of the volunteer respond, a lot of time, people respond in a negative way, right? If you call the radio, like if the radio throw out a question, please call in to give your opinion and stuff like that. Most of the time, you know, there's sometimes people call and give good positive feedback, but most of the time, more than often, people call because they have some negative, you know, effect on the product or something like that. So again, it's still randomized because it's randomly people call, but most of the time volunteer will not give you a fair assessment. People still do it just to have some way to collect your data. But again, those are the 5 different techniques that we will collect our sample. Okay, and again, on your homework, they will ask you, given this description, what kind of technique you have or what kind of technique are you using. Okay, so you can see if you can do the homework and look further more in terms of that item. The next thing we have is basically the terminology that we were using, which is, again, the data set is basically the collection of your information. And inside the data set, we have an individual, which is, again, the information that you want to collect, meaning you want to collect the student, that is will be your individual, or do you want to collect the animal, the plane, or the car, right? Anything that you want to collect, that is your individual. And inside the individual, there is a variable, which is the variable basically tell you what kind of item are you collect it with the student. Do you collect the student age? Do you collect the student weight? Do you collect the student height? Or do you collect the student ACT score, right? If you collect the plant, do you collect how long it's been soil, how long have been water, or how high the plant or something in that nature? So each variable is basically the characteristic. And the last item inside the variable is the actual data, which is the data is the actual value of the individual, the variable, right? So again, for instance, the student age can be 25, 21, 25, 30. Those are my data, right? Collect that data, but that data relate to the student, which is the student age, which is the variable, and the variable relate to the individual, which is the student. So again, if you look at this thing here, if you came from 120, just imagine that, you know, the Venn diagram, the central one, the smallest thing is your data, which is your individual item. And then the variable is the second circle that include the data, which is the name of the data that you want to collect. And the individual will be outside, and the data set will contain all of this thing here. Okay, so the outer layer, inner layer, and then the most inner one is your data. So again, one thing is I don't think they ask you this question on the test or on the homework. It's just easy for us. If I tell you a variable, you say, okay, variable can be the height, can be something like that. And if I say the data, you know, oh, that's you talking about the number itself, right? So those are the 2 things that you hear a lot, which is the variable and the data. So inside the data, there are 2 types of data or 2 types of variable that we have. So there are a qualitative data versus a quantitative data of variable. Okay, and again, I can interchangeable the data and variable because again, the variable is the item we collect and the data is the actual number that we collect. So it's the same, right? But go back to qualitative data or qualitative variable is basically, sometimes you hear them say categorical, which is category, right? So as long as your data or your variable, you can put them in different category, then that will be your qualitative data. As you can see, gender will be qualitative, color will be qualitative, or type of model of the car will be qualitative, right? And to be quantitative, think in terms of quantitative will be the amount, the actual number of item you have, right? So again, the age, which is the numerical item, or the mileage in your car, or the weight, right? Those will be quantity. So I tell my students to make it easy. Just think in terms of quality versus quantity. So what is quality? Quality can be good, okay, bad, right? Meaning that's your category. Your quantity, your quality is your category, and your quantity is how much of the item you want. So anything related to number would be quality. I mean, sorry, quantity. And anything related to category would be quality, which is again, qualitative. But one thing is not all number is quantitative, ladies and gentlemen. For instance, zip code is not qualitative, right? Zip code doesn't tell you the amount of item, right? That number doesn't tell you how long you stay there, right? So zip code is just qualitative, meaning again, it's just category, right? You live in this area, right? Or the area code is qualitative because the area code, the number 504, it just tell you, oh, you're in the New Orleans area, right? It doesn't tell you the number of how much, right? So not, often quantitative relate to number when they tell you how much of the item, okay? So inside qualitative item, your category, there are two types of item you have, which is a normal variable and ordinal. Ordinal is basically if your data, you can put them in some order, some ranking involved, then you put them in ordinal data, ordinal item, right? Which is again, if you have a letter grade, which is there are some ranking A, B, C, D, E, and F, well, no E, right? D and F. And again, size of substring, meaning anything that you can put them in some ranking order, then is a ordinal, right? And nominal is basically if you cannot put them in any specific order, or the order is not important, right? There's no, as you can see, the phone number, your phone number is not important than my phone number. Well, to you, it might be important, but again, the zip code and state of resident, those doesn't have any specific order, right? You might argue and you say, oh, the state of resident, people live in a high income area and stuff like that. But again, in general, the state of resident doesn't have any rank in total, okay? So looking at this thing here, ordinal, you can put something in specific order or some ranking involved. Nominal, there's no ranking at all, okay? And there are two types of quantitative, which is the amount of thing, which is the discrete variable versus continuous variable. So again, discrete variable is basically, this is what I tell you, my student, is the discrete variable is when your number, remember your quantitative data is deal with number where the amount of something occur, right? So when your amount of something that if you can only count in terms of a fixed number, in terms of 0, 1, 2, 3, 4, 5, then it will be discrete. Discrete meaning is a whole number or counting number, right? Meaning, as you can see, the number of siblings that you have, which is you either have 0 sibling, you by yourself, or you have 1 brother, 2 sister, or something in terms of a whole number. You might argue, oh, I have 2.5, right? But again, it's a whole person, so you cannot count half of a person, right? The number of electrical outlet in a house, again, even though the outlet is broken, it still count as 1 outlet, right? So again, it is, you either have 1 outlet, which is hopefully not, you have 10 outlet or 13, meaning again, you don't have a portion of the outlet, right? It cannot be one work and the other one would not work. It's still the number of outlet, right? Again, for continuous variable is whenever your data, you can break down to different interval, then we call this continuous because we don't really know exactly the exact number. For instance, you say, okay, from my house drive to Delgado is 12 minutes. is it really 12 minutes exact? Or is it 12 minutes and 31 seconds, or 12 or 11 minutes and 58 seconds, something in that nature? Meaning, one thing is, if you can break down your data, if you can break down your number to different interval, then it's continuous, because we don't know exactly what we have. In the sense of if you say, oh, my the diameter, say outside is 99 degree, is it really exactly 99 degree? So if you can break down to a small different interval, then we say continuous. Okay, like if you look at this thing here, you say the height of the person, you say I'm 5 feet 4 inch, right? Are you really 5 feet 4 inch exactly? You might be 5 feet 3.5 or something in that nature. So in terms that you can break down to different interval, we say continuous. So again, most of the time you see that the number of something will be most of the time discrete, because the number, you only count them, right? The number of pen you have. And you look at this thing here, the one question a lot of students ask me is, wait a minute, Mr. Tran, over here, the age of the person is continuous, but the age of the person at his or her last birthday, why is discrete? Why is the age? So one thing is, in general, the age is continuous. Like the age, you are constantly living, you are constantly, sorry to say, but getting older, right? So continuously is that, right? So if I ask you how old are you, well, you say I'm 26, but you're not really 26, right? You're 26, 3 months, 4 days, 2 hours, 15 minutes. Now keep on counting the second, meaning you can break down to each interval, and that's why they are continuous, right? But this one here, the person at their last birthday, well, if we know their last birthday now, that is the exact moment, right? That's the exact number. Last birthday, you were 21, right? So again, that's the exact number. Okay, so again, that's the difference why the age over here is discrete versus the age over here is continuous. Okay, and again, and other stuff, I think you can question with discrete versus continuous, quantitative versus qualitative, sample versus population or parameter versus statistic, ordinal and nominal. All right. So we are the last chapter of chapter 1. The last section of chapter 1 is 1.3, which is they basically tell you, most of you probably won't do it, but when the thing is, when you do it, you will know exactly how to design your study. So in 3.1, they mention a lot of different technique, different way to design your study. But the one thing that I want to point out, that the difference between experimental study, experiment study versus observational study is, the experimental study is whoever conduct the study, you will physically do some item to your subject, right? Meaning again, you actually give the item, you actually do something to see how the effect is. So you physically go in there and do the experiment. That's why they call experimental study, right? You changing this, you changing that, you know what to do. The observational study is basically you don't do anything. You don't even know the process. Well, you know the process, but you don't know what they given you, or what the people given to the item, right? The placeable effect, right? For observational, you just go in and you just write the outcome. You don't know if the patient get the candy or the patient get the medicine. You just observe. You say, okay, day 1, this patient, this. You observe. You don't even know if that patient get cured by drinking the medicine or eating candy. So again, observational, you don't know what you have because you just observe. And experimental, you know exactly what you doing because you are the one who given the item or alter the effect. Okay. So again, that's the only most important thing in 1.3 is know the difference between versus observation. They have other things. They have blind, double blind, co-founded, and the different technique. But again, you can read through in your ebook, or if you have an ebook up there, or if you have a textbook, you can read it through to see the item. But like I say, when you get to when you need to design a study, then you will know exactly what you need. Okay, but no, that for now, just know that there are two different kinds of study, which is experimental versus observation. So we are done with chapter 1, ladies and gentlemen. Like I said, chapter 1 is just definition. They don't have any no, they don't have any application. They just want you to know the definition, want you to see the difference between the definition, and mostly in chapter 1 they ask you a lot of definition. After chapter 1, I don't think they ask you a lot of definition. They just ask you how to do the problem, right? If you look up here, you see, oh, the frequency, which is again basically how often does your data occur, right? And then frequency distribution table, which is again the table that represent the pretty much you tally up your data. And your relative frequency is basically we want to find the percentage or the relative item based to the data, right? So again, they won't ask you what the definition. They basically just ask you to find the relative frequency, find or construct the frequency distribution table. Okay, so again, only in chapter 1 they ask you a definition. After that, they just basically you have to understand the definition for you to apply to the problem. So in a sense, one thing I want to point out that the relative frequency, right now you will hear relative frequency. When we get to chapter 4, you will hear the probability. So one thing is the item is the same. The way to do it is the same. It's just the changing the name. So it's not something new. It's just changing the name. So relative frequency is basically tell you to take the frequency, divide by the total all of your frequency, right? The sum, which is the total frequencies, okay? So let's take a look at this item here, which is 2.1. We all deal with a qualitative data. So what is a qualitative data? Which is hopefully you remember qualitative, which is quality, which is category, which is, as you can see, in this case, this is my category, which is, I don't give you the background of this data, but looking at this thing here, basically this is the grade of my 35 student, right? Let's say that this is the 35 student took my test 1, and this is the grade that I have, right? And now they ask you construct a frequency distribution table, calculate the relative frequency of each category. So we know the category, which is this. Let me ask you guys, this thing here, is it ordinal or nominal variable? Again, if this was the grade, then this would be ordinal, right? The grade have the ranking, which is again, A is better than B, B is better than C, C is better than D, and D is better than F, right? So again, this will be ordinal. But anyway, let's go back to this thing here, which is to construct your frequency distribution table. And if you came from 120, it's the same idea. It's basically looking at this thing here, list out your class, which is in this case, because it's a category, because it's a qualitative data. My category is either A student, B student, C student, D student, or F student, right? And then you just go into your raw data and ask yourself, well, how many A students do I have? Which is in this case, I have 6 of them, which is the frequency will be 6. I have 6A, which is that is my frequency. That's how often does the A appear. And then you go in and you tally, which is how many B you have, which is in this case, you have 7B, which is again, looking at this thing here, my frequency is 7. Similarly for C, we have 9, right, 9C. And again, similarly for D, we have 6. And lastly, the leftover is, which is again, looking at this thing here, we have 7. And to make sure, one thing to check yourself is, if you add the frequency, if they are equal to 35, then most likely, unless you do double 2 of them wrong, then they come out right. But if you if this number is like 36, you miscount somewhere. If it's 34, you lost someone along the way, right? So looking at this thing here, this is what we do in terms of frequency distribution table. So again, basically tally up your data. That's all you're doing is you tally up your data, right? So now, how do we construct a relative frequency? Which is to construct a relative frequency. Reminder, relative frequency is basically take this frequency, which is for A, I have 6 divided by the total frequency, which is 35, which is, as you can see, all we're doing is we take 6 divided by 35, which is 0.17. Similarly, I have to take 7, which is the frequency, divided by the total, which is 35, which is, that would be my result. And same thing go, which is I take 9 divided by 35, and so on and so forth. Okay, so again, relative frequency, that's all you do is you take each individual frequency and divide it by the total frequency. And like I mentioned, later on when we get to chapter 4, they won't call relative frequency, they will call probability, right? Which is probability is the same as probability is the same as relative frequency, right? They will tell you if you go into this data, this data, what's the probability of you select an A student? Well, the A student is you have 6A out of 35, which is 17%, right? So one thing is your relative frequency will always be in decimal. If your relative frequency is a whole number, you did something wrong. Okay, so your relative frequency will always be a decimal because you take a small frequency, divide by the total overall frequency. Okay, the other thing is if you want to check, if you add all of your relative frequency up, it has to be equal to 1, which is the total probability is 100, or the total percentage of the item is 100, okay? So again, for us, this is all they ask you is frequency and relative frequency. I don't think they ask you cumulative frequency. If they ask you cumulative frequency, cumulative is basically add them up, right? Cumulative, which is the first one here, which is 0.17, you add to this item to give you 37, you add to give you 56, you add to give you, basically you accumulate along the way. But again, other book they have it, this author does not focus on the cumulative frequency. But anyway, question here in terms of how I find my frequency and how do I find my relative frequency. And again, that is 2.1, which is, 2.1, we deal with a qualitative data. And that is just one on your homework. You might collect the model of the car, right? Toyota, Ford, Honda, Nissan, GMC, Dodge, meaning again, or the type of credit card, Visa, MasterCard, meaning again, any category item, right? So in 2.2, which is now we are deal with a quantitative data. And if you remember quantitative data, which is we involve a quantity or a number of item, right? And your data will involve number rather than category. So because it's deal with number, sometimes your number will have a big range. And because it's a big range, we want to make them or put them in a class. Rather than list individual number, individual quantity is too big. We want to make it in a smaller distribution table, so we put them in a class. So one thing is in each class you will have a lower limit, which is the smallest number we have in the class, and the upper limit, which is the highest number in that class. And within the class, you will see that there is a class width. The class width is basically, again, the width of something is how big the item is, right? So class width is basically how big is your class, okay? So in the sense, the class width, you will see that basically each time you jump from one class to the next, that's how many units you have to add. That's what your class width is, okay? So the recommendation or requirement, not recommendation, is requirement, stronger than recommendation. Requirement for your class is, again, every observation, all of your data have to be in the class, right? And your class cannot be overlap, meaning one number cannot be in one class and also in another class. And each class would have to be equal, meaning we cannot have one class have 10 data and the other class have 12 data, right? And again, there's no gap in between, meaning from one boundary to the next, there's no gap in between, okay? So looking at this thing here, let's take a look at this item, which is your histogram. From your frequency distribution table, we can construct the histogram. And one thing I want to point out that the histogram, the difference between the histogram versus the bar graph. The histogram versus the bar graph is the bar graph. We use the bar graph in qualitative data, meaning in category. Then you use the bar graph, meaning again, how many people using MasterCard, how many people using Visa, how many people using American Express, how many people using Discovery, meaning those are category. So we can just put a bar for Visa, the bar for MasterCard, the bar for American Express, and so on and so forth. It doesn't make any difference. Now, the reason why we use the histogram is, first of all, the boundary, all of this thing here, they have to meet each other, because your quantitative data is a number, which is the amount. So all of them touch each other. That's the first thing. Is for histogram is your bar have to touch each other. The second thing and most important thing is your horizontal item, your horizontal unit will always be your data. So whatever the data, whatever the number that you collect, it will be down here. If it's the age, it will be down here. If it's the weight, it will be down here. If it's the test score, it will be out here. Again, the test score, not the previous test score. The last previous test score is ABC. In quantitative test score will be 50 to 60, 61 to 70, and so on and so forth. Okay, so again, those will be your test score in a quantitative data, which is the actual percentage of your number. Okay. And the other thing is your vertical line, your vertical item right here will always or only be your either frequency or your relative frequency. Okay. So again, those are the most important thing is your data will be on the horizontal and your frequency will be on your vertical. And there are three different shapes that we have, and this is what they will ask you a lot. And you will see that in statistic, is weird. In statistic, a lot of the time we have this indirect relationship. Okay, so first of all, let's take a look at this thing here. Your histogram, you can have a symmetrical shape, which is looking at this thing symmetrical shape. If you came from 120 or if you heard of the bell-shaped curve, this is what symmetric is, in the sense that, you know, is the middle of the pack is the highest and the further away is slowly decreasing and slowly decreasing in terms that is balance them out, right? So this thing here, when it's look like this, is symmetric. And over here, we say that it's skewed to the right or positively skewed. And you probably say, wait a minute, Mr. Strand, I took algebra and my algebra teacher tell me that from left to right, if it's decreasing, then is negative slope. I agree with you. That is algebra. But I'm sorry, we're in statistic class. Just kidding. I don't know who make up this thing here. One thing I can tell you that, you know, when they say this positively skewed, is basically from the graph perspective looking at you, not from your perspective. Like I say, this thing here has always been in the statistic book. And one thing you will see that in statistic book, a lot of the time they have that indirect relationship. It's like they want to change in the rule from algebra. But again, it's always been this way. So one thing to tell you is if from left to right, if they are descending, then we say that skewed to the right. Okay, which is, again, if you look at this thing here from the graph perspective on the graph hand, right? Again, on your left, when you look at it's on your left, but the graph is on the right of the graph looking at you, right? So looking at this thing here, if it's like this, it's positively skewed or skewed to the right. And if it's ascending from left to right, if it's ascending, we call it a skewed to the left. Okay, it's the opposite from algebra. Okay, so don't use the algebra linear graph for this shape. Okay, so again, symmetric easy is the inverse of the algebra. So this would be skewed to the right, and this will skew to the left. Okay, so now let's take a look at this example. So the one thing that they will do is they will ask you to construct a frequency distribution table for your quantitative data, which is looking at this thing here. We can disregard the story. Sometimes the story confuse you more. So again, we can skip the story. This is what we have. This is the raw 60 data we have, right? We have 2, 4, 6, 2, 4, 6, 8, 10. So we have 60 data, which is the 60 dimension, right? Period. So look at this thing here. We have this 60 data. So they ask you for A, they ask you construct a frequency distribution using the class width of phi. So this is good, right? If you look at this thing here, this question, they spell it out for you, right? They spell it out. They want you to use the class width of phi and using 55 as a lower limit. Later on, if not today, on Tuesday, we will run into a question that they don't spell it out, and we have to pick our own lower limit and choose the class. So we will do that later, but for now, let's take a look at this thing here, which is they tell you we want to use the class width of phi and the lower limit of 55, which is, again, they have this, which is they tell us the lower limit of the first class is 55, which is, that's my lower limit, right? So remember, what is the class width? I told you guys that the class width is every time you jump from one class, which is my first class is 55. And if I jump to my second class, I need to add 5 units, which is from 55, I add 5 to give me 60. From 60, if I jump to the third class, I need to add 5 to give me 65. And the third class, I need to jump, I add 5, which is, again, reminder, we have to include every single data we have, which is, if you look at this thing here, if you glance through this thing here, the smallest data we have is 59, and the biggest data we have is next to it, which is 116. So again, I look at a lot. So those are the two numbers. The smallest number is 59 and the biggest number is 116. Reminder, we need to make sure that we include every single data. So again, 115, my upper limit will include the 116, right? So now, how do you find the upper limit? So one thing is the upper limit, right? The upper limit is here. Remember, your class, we have a lower limit, which is the lower limit we did. They tell us the lower limit is this item. Now we need the upper limit. So how do we find the upper limit? Pretty much, easy enough in terms that the upper limit will be 1 unit less than this, right? Because we don't want any gap, 1 unit less than this, which is, again, is 59, right? So 1 unit less than 60 will be 59, and 1 unit less than 65 will be 64. Or if you take a look at this thing here, every time you jump, you add 5, which is 59, add 5 to give you 64. And again, if I add 5 to give me 69, if I add 5 to 74, and so on and so forth. So basically, the upper limit right here is basically 1 less than the next lower limit. 1 less than the next lower limit, 1 less than the next lower limit, 1 less. Everybody see that each of this thing here is 1 less than the lower limit.
Dealing with decimals.
What's that?
Well, what if we was dealing with decimals? Would it still be 1 unit, or would it be like 1 decimal place?
1 decimal place.
Okay.
So this is one thing is on your connect map. If your data, so this is the rule, keep this rule. And if they change on you, let me know. But if your data does not have a decimal, if you look at this data here, if your data does not have a decimal, then the upper limit will not have any decimal. If your data, for instance, in here, your data have like 96.2, 103.5. If your data have a decimal, then the upper limit will have a decimal, which will be 59.9, 64.9, 69.9 because of the decimal. So we don't want a gap. So we want to go to the decimal place. Everybody understand in that nature?
Got you.
All right. So again, just look at your data. Look at the data that they give you. If the data they give you is 2 decimal place, then you have to put 59.99. If your data is only 1 decimal, then you just put 59.9. In this case, my data, my raw data doesn't have any decimal. That's why I don't put any decimal here. Okay. So once we have this, which is the lower limit and the upper limit, once we have that, now the only thing we need to do is we need to go in and we tally up your data, right? How many data is between 55 and 59, which is in this case, if you can do all of them, there's only one data, which is 59. That's the one data that is between 55 to 59, okay? And again, how many data between 60 to 64, which is, again, there's only one, which is 61. And again, how many data between 65 to 69, which is 1. How many data between 70 to 74 is 1. And again, there's no data between 75 to 79. And the rest, again, I go in and I tally up, which is, again, that's all you do, right? You go in your raw data and you tally them up. You say between 1, you put 1 line, 2 line, 3 line, 4 line, 5, 1, 2. And again, this is what we have. And in order for us to make sure that we have the right item, basically you just add the 1 plus 1 plus 1 plus 1 plus 4. You add them up to see if it's equal to 60, right? Because we have 60 total data. If it's not equal to 60, we miscount somewhere. If it's more than 60, we overcount somewhere. Not often that is equal to 60 and then you have something wrong. I mean, unless you do 2 things wrong and then it come out to be equal to 60. But oftenly, if you make 1 mistake, you will know in terms of that, okay? And ladies and gentlemen, the reason or the purpose of this class, is if you look at this thing here, like I mentioned, the highest data is 116 and the lowest data is 59, right? If you take 116 minus 59, that will give you 57 data. I mean, not 57 data, 57 spaces between the smallest data to the largest data, right? You have 57, the range of your data is 57 data, 57 steps, right? You don't want to list 50, you don't want to list them individual. You don't want to list like 59, 60, 61, 62, 63, all the way up to 190, 116. If you do that, when you find your frequency, you might have like 1, 0, 1, 1, 1, 1, 2, 0, 3, 1, 1, 1, 0, 0, 0, 0, right? Meaning that will not tell you much because you just say, oh, my data is scattered. And that's why they want to put them in a class. They put them in a group so that you can see that they are in specific group that you have. And that's why we have a class in a quantitative data, and we don't need a class in a quantitative data that we need a class, and qualitative data we don't have to have a class because it's just a category. Okay. So anyway, question here in terms of my frequency distribution table here, how I come up with this frequency distribution table. Any question at all? All right. So after you find this frequency distribution table, the next thing they have is they will ask you to construct a histogram. So how do we construct the histogram? Which is the histogram is easy, right? The histogram is easy in the sense that all you need to do is make sure that we have this item, and make sure that your horizontal item is your data. And again, I think my data, the name of my data is wrong. I think it's the dimension rather than the duration of the eruption. I think the data is the dimension, which is how long is stop item. But anyway, make sure that your horizontal is your data and your vertical is your frequency. So again, for me, this is my frequency, which is the highest frequency I have is 23. So I go up to 25 to make sure I include them. And again, instead of list 0, 1, 2, 3, 4, 5, I just jump 5, 10, 15 to make my data a little bit short, right? To make the height of this item short. But again, all you do is you just go in from 55 to 60. The frequency is 1. So you go up to, estimate to 1 and you put that. I think on your connect math, you have that finger, you just click on it and drag and you see the number, they have the number 1, 2, 3 right here. I just guesstimate it, right? Just to have a idea that this is 1. This might not be exact, but again, do you agree that the first 4 item I have, the first 4 class from 50 to 60, I have 1, from 60 to 65, I have 1, and so on and so forth. From 75 to 80, I don't have any, which is the next one I have is from 80 to 85, which is again 80, 85, I have 4. I might touch the 5, but again, just imagine that is 4. And again, the next number I have is 11. And again, 23, 12, 3, 2, 1. So looking at this thing here, this is pretty much, this is your histogram. And again, your histogram, like I mentioned, you just put your lower limit from 50 to 60, and that's why the boundary is there, and so on and so forth. Okay. So again, this is not really overlap the 60, it's just that they meet exactly at 60. Okay. So again, looking at this thing here, question of how to construct the histogram. And one thing, ladies and gentlemen, I want to point out that this thing here, I know if you look at this thing here, and if they ask you, given this thing here, is the shape of this thing here symmetric or skewed to the left or skewed to the right? This thing here is not really symmetric. The reason why it's not symmetric, because you probably say, wait a minute, why it's not symmetric? It's look like, like that to me. But the reason why it's not symmetric, because the highest peak is not really in the middle of your data. It's kind of slanted over from our perspective. It's slanted over to the right a little bit, right? So again, if you were to take this item out, if you were to take this 2 item out, if let's say if we x this 2 box out, then yes, right? If you block those 2 item out now, this is symmetric. It's it's go to the highest peak, then it's go down. But because of the reason why the original item is not symmetric is because we have more data slant over here, right? Not slant over here. We have less data over here and more data slant to our right. So if you have to, if they have only 3 choice, if they say it's symmetric, skewed to the left or skewed to the right, this thing is skewed to the left because again, it's the left of the graph, right? Remember, if it's on our right, it's on the left of the graph. So it's kind of slanted over to the left a bit because they are, this item here is more to the left than it's more to the right. Okay, so again, if they have none of the above, then this mostly none of the above. If they have 3 options, symmetric, skewed to the left or skewed to the right, this thing here is skewed to the left. Reminder, is the opposite of what you look at. Okay, so again, like I say, if you throw away this endpoint and you throw away this extra stuff, then yes, this by itself somewhat symmetric. But because we take that the whole entirety of this thing here, so they are not symmetric because the peak of the item is more to the left of the graph. It's more to our right, you know. So again, it's more to the left of the graph. That's why it's skewed to the left. Anyway, question of how to construct the histogram, how to construct a frequency distribution table here. All right. And if you already expected, yes, the next question they will ask you is how can you construct a relative frequency, right? So again, you know, like I mentioned, they won't ask you what is relative frequency. They won't ask you the definition. They just ask you construct the relative frequency. So looking at this thing here, reminder that this is our table. This is our previous table before. Let's see. This is our previous table. Yes, negative skew. So looking at this thing here, looking at this item that we have is, again, how do we construct our relative frequency, which is, if you remember, your relative frequency is, we take our frequency and we divide by the total frequency, right? So again, your data is the same. Your data is the same as this, which is, again, my lower limit, my upper limit. The only thing different now is, again, for the first class, maybe accidentally unmute. But again, looking at this thing here, we just take the first class, which is the first class. We have 1 divided by the total number of data we have, which is the total number is 60. So 1 divided by 60 is 0.017, which is, again, forget the 0.9 right here, ladies and gentlemen. I did not edit this. Again, it's just 55 to 59. Disregard the 9 here. You know, I make a mistake last time and then I forgot to edit. But again, your relative frequency is just that, right? You take 1 divided by the 1 divided by the 60. One thing I want to say here first is, this class, we have kind of 3 different way of decimal, or 3 different way of routing. One way is they will tell you how many decimal they want it to be. So in this case, I want 3 decimal place. So again, the rule of routing is the same, right? Anything to the right, if it's 5 or higher, I increase and I left that. So if they tell you exactly how many decimal they want, that's how many decimal you want to give them. If they don't tell you how many decimal they want, the rule of thumb is, if your data have no decimal, then you give them 1 decimal place. If your data have 1 decimal, you give them 2. So you always give them 1 extra decimal place than your data. That's the rule of thumb if they don't specifically tell you how many decimal place they want. Some of the homework question, they say route to 4 decimal place. If they tell you route to 4 decimal place, you have to give them 4 decimal place. If they don't ask you specifically how many decimal place, then you have to give them 1 extra decimal than your data. So okay. The other rule of routing in this class is, if we deal with discrete data, connect back to discrete data. Remember, your discrete data is either 1, 2, 3, 4, 5. So if we deal with discrete data, we always route to the next whole number. So again, we cannot count 2 3/3 of a person. We have to go up to 3 person, right? So discrete data, you have to go up to the whole number. So again, we will get more of that. We will expose to those later, but I just want to tell you now. So keep in mind that there are a little bit different route and like decimal place that they want. Okay.
You said if they don't have a decimal thing in your equation, then when you do the relative frequency, you add 1. But in this equation, they didn't have 1 and you added 2.
No, this one I specifically I wanted 3. So this one I wanted 3 decimal place. Yes, if they don't tell you, this one here, I did not write it there, but the problem itself, I did not copy it down, but the problem itself is they tell you that they wanted 3 decimal place.
Okay, thank you.
Yeah, but yes, you are right. If they, and the reason why I keep 3 decimal place here is because if you only give them 1 decimal place, you will see the 0.0, and all of them is not all of them 0.0, right? Because there are some numbers. So and then if you put 0.02, you make it too big. So again, that's why. But again, the problem itself, they ask you for 3 decimal place. I did not type it here because I kind of run out of room, because when I type it, I run out of room on the bottom. So I just put that and I tell you I want 3 decimal place. But again, go back to relative frequency. As you can see, 0 divided by whatever is still 0, and 4 divided by 60 to give me 0.67. And again, I do the 11, which is again the 11 divided by 60 to give me 0.183. And then I do the 23 divided by 60 to give me that. And again, you can do the rest in terms that you can take 12 divided by 60, 3 divided by 60, 2 divided by 60, 0 divided by 60, and so on and so forth. Which is, again, looking at this thing here, your relative frequency is this item here in that nature or in that form, okay? So again, no, relative frequency is not that difficult to do. It's just basically take your individual frequency, divide by the total overall frequency, right? And then just depend on how many decimal they wanted, right? So again, first of all, question with this thing here. Question with relative frequency or frequency distribution table or any item that we cover so far.
Where did you get the 60 at? I understand like how to divide it, but where did you get the 60 at?
The 60 is the total. The 60 is the total data we have right here.
Oh, okay.
If you count all this data, this is your 60 data.
Oh, okay.
Right?
Thank you.
Individual data. So again, that's your data. That's why we have 60, because the data tell us that we have 60 dimensions, right? So again, each individual is 1 data, so you count all of them is 60, and that's where the 60 come from. Okay. Or if you add your frequency up, remember the formula for relative frequency is if you add your frequency, if you add all of this thing up, is equal to 60, and that's where the 60 come from too, right? If they don't tell you how many data, you can just add all of your frequency up and it should be equal to 60. And if it's not, I did something wrong. Okay, but again, this is your relative frequency, and sometime on Connect Math, they give you the whole table. They give you the class, they ask you to find the frequency, and the next column they ask you to find the relative frequency. This one here, I just do it separately. I do the frequency on one item and the relative frequency on another one. So first of all, question with any of this thing we went over. All right, well, if you don't have question, let's stop here for today. And then we will pick up more on this. We will continue or finish this item on Tuesday. So